Okay, now there is in electricians use a transformer step to step the 230 VRMS to a mains voltage down to 115 VRMS. Okay, so it means it will step down to 115, around half of it. Now the secondary coil has 500 turns. Oh, sorry, should not call 500 turns. So, and is connected to a resistor of 5000 ohm. So A, calculate the number of turns on the primary coil. B, calculate the current in the secondary coil. C, calculate the current in primary coil. Assume that the transformer is 100% efficient. D, the electrician connects the cable to a secondary coil that breaks down when the potential difference between the wire and earth is larger than 130 volts. Explain why, whether the break cables will break down when the transformer is switched on. Okay, now A. So I need to find what is the primary coil. So using this equation, NP over VP equal to NS over PS. Okay, NP is the primary turns of a primary coil that you have to find, and the primary voltage is 230. So the secondary coil, the second number of coil in secondary is 500, and the potential difference that it produces 115. So number of turns in a primary will be equal to 1000. Okay, B. Okay, B want you to find calculate current in the secondary coil. Okay, so in the secondary coil, I have because it's connected to a 5000 ohm with a 115. Okay, so I can find my current over here when V equal to IR. Okay, so your V here is 115. Okay, your I here is what you have to find at 5000. Okay, so your I will be 0.023 ampere. So be careful here. Everyone is a VRMS is RMS. Okay, so this all is a root mean squared value. Okay, now C, you have to calculate the current in a primary coil. Okay, I have to calculate the current in the primary coil. So again, assume that the transformers have a 100% of efficiency. Okay, so means that my power for the primary coil will be equal to power of the secondary coil. Okay, so my IP times the VP will be equal to the IS times the VS. This means that the current of primary coil times the potential difference of primary coil equal to the current of the secondary coil times the current of the potential difference of the secondary. So I have IP, which I have to find. VP is 230. Okay, current of secondary is 0.023, which we found it in the part B, and the potential is 115. So IP will be equal to 0.0115 ampere. So it's lost 0 over here. Okay, now in part D, it said that they use the current they're going, they use a cable, okay, and the cable only can last of 130 volt. Means when it's larger than 130 volt, the secondary coil will break down. Okay, so they want to ask you whether that this transformer will break the current, break the wire. Okay, so what I have to find here is actually the V naught. Why? All the value that given here is actually the VRMS value. So again, I remind you all, when you see all the electronic instruments, okay, that will state what is the power, what is power. Actually, it's all are VRMS. Even all the power that coming into the power supply is all is in VRMS. 230 volt is a VRMS. So here, the VRMS in the secondary is 115. So my V naught here, it should be 115 times square of 2. So it should be 163 volt. Oh my god, it's larger than what is supposed. So this electrical engineer failed. Okay, so it break.